Hello Algebra 1 students, and welcome to Lesson 23. Today's lesson is about the surface area of pyramids, cones, and spheres. Last lesson we talked about the volume of pyramids, cones, and spheres. So the natural extension is, well, let's talk about their surface area. So overall, we're kind of gathering this knowledge base of different formulas for surface area and volume. So today is, of course, going to be a very formula-heavy lesson. That's why I recommend that you have your notes ready to write down any formulas that I might be throwing out to you guys, because I expect you to be remembering these. All right, and so let's start with pyramids. Remember, a pyramid is a polyhedron that has one polygonal base. In this case, this is a hexagonal pyramid, because the base is a hexagon. The surface area of a pyramid is the area of all of the faces of the pyramid. So just imagine taking that pyramid and unwrapping it, basically separating all of these triangular faces and folding them outward. What you get is this shape. So for any pyramid, no matter how many sides the base has, you have these triangular faces that you have to find the area of. So as a general rule, the surface area of a pyramid is just the area of the base, which is this guy, plus the area of the triangles. So all 6 of these guys, or if your base was a pentagon, you'd have 5 triangles. If your base was a square, you'd have 4. But you do have these triangular faces, all of them identical, that you need to find the area of in order to find the surface area of a pyramid. So I will be more specific about how to find the area of the triangles soon, but this is a good general outline. So example 1, let's find the surface area of a regular square pyramid like this one. Dimensions are in inches. Okay. So remember that the formula for surface area here is the area of the base plus the area of the triangles. And so this is a relatively complicated term that we have to figure out. But I know the area of the base at least, right? The base, they said it was a square pyramid, so that means the base is a square. And they also gave us the length of one of the sides of that square. They said the length was 10. So to find the area of a base, like a square with a one side length of 10, that's 10 times 10. And so 100 is just the area of this base. But we haven't talked about all of the surface area, right? Because we also have these triangular sides. We have 4 triangular sides that we must find the area of. So let's start with one of the triangular sides. Since we know that the base is a square, we know every single one of these triangles is going to be identical. So I'm just finding the area of one triangle times 4, right? Because there's 4 identical triangles. Now, with a geometry problem, the idea is you're taking what you do not know and you are trying to replace it with some numerical values so that you can finally evaluate the surface area. Now, what we have to do is just use our intuition and really think about this as a solid object living in space and trying to find the measurements of that object. Remember, when we find the area of a triangle, the formula for the area of any triangle is 1/2 base times height. So it's our job really just to find out what's the base and what's the height. So if I replace area of a triangle with 1/2 base times height, am I talking about the height of the actual pyramid? Or am I talking about the height of the triangular face itself? In this case, when I say h, I don't mean the height of the entire pyramid. I mean the height of the triangular face, which in this case is actually the slant height, 13. They gave us that. And the base of that triangle, since it's the same as the length of this base, it would be 10. So it would be 10 times 13. So when we are finding the area of triangles on the side of a pyramid, the key is that we use the slant height. Now, slant height is the distance from the vertex to the center of the base below. It kind of gives you a measurement of how tall this triangle is. So simplifying this, 1/2 times 10 plus 13. 20 times 13, so 260. 100 plus 260 is 360. And our units are in inches squared because this is units of area. So we started by writing down the formula for surface area, clarifying the formula by replacing the area of the base with that known value of 100, and replacing the area of the triangles right here with a more clear expression about what we were actually doing. 4 identical triangles, all arranged around a center point. Finding the area of one of those triangles will lead you to finding the rest, right? Because they're all identical. This one, I will let you guys do yourself, okay? Find the surface area of a right square pyramid. The length of a base side is 16 inches, and the height of the solid is 15 inches. The slant height of each lateral face is equal to 17 inches. So let's draw a picture. I've got a square pyramid, right? That's usually what square pyramids look like. Might look a little wonky, but that's okay. The length of a base side is 16 inches, and the height of the solid, so the height itself, so how tall it is 15 inches. The slant height, which is actually what we're looking for when we find surface area, is this length right here. A slanted height, distance from the center of the edge to the vertex. The slant height of each lateral face is equal to 17 inches. So in order to find the surface area of this shape, what we have to do is first write out the formula for surface area. That is the area of the base plus the area of the triangles. Just imagine this guy. Imagine this pyramid folded out, right? If I take all of those sides and I unfold it, almost like this is a gift box or something and I'm unwrapping it. Now I know that I have to find the area of the base, and then I have to find the area of these 4 triangles. I know all 4 of them are the same, so that'll help me out. So first, let's try to find the area of the base. The length of a base side is 16 inches, so I know that my area of the base would be 16 squared. 16 times 16 gives me the area of this square. We have to add the area of the triangles, plural, meaning these 1, 2, 3, 4 different triangles. The way that we do that is we just do 4 times the area of one of them. And it's not that hard to find the area of one triangle. You just do 1/2 times the bottom of that triangle, which is 16, times the height of that triangle, which is actually this orange slant height right here, 17. Now there's a little bit of canceling that can be done, even though overall the calculation is somewhat nasty. And so we're just doing 16 squared, cancel those out, plus 32 times 17. And yes, this is not allowed during a test, but of course we can just real quick check if this is right. 16 times 16 plus 32 times 17 gives me actually exactly 800 inches squared. It's kind of cool that, even though they set it up in a somewhat obfuscated way, our answer turns out to be relatively nice. So 800 inches squared is the surface area of that pyramid. Now let's look at cones. Remember we did volume of a cone last time and it actually turned out to be pretty similar? Well, a cone is like a pyramid, except that its base is a closed curve instead of a polygon. The surface area of a cone is the area of the base, right, the circle at the bottom, added to the product of pi, the radius, and the slant height. The reason that is, well, I'm not going to get into the exact reason that it is because it does take a little bit of work to prove that. But just imagine taking this. Maybe you had some kind of gift and you unwrapped the gift package that looked like a cone. And you're left with a circular piece, and then you're left with this part that kind of came around the cone and made that pointy bit. So here, the vertex of the cone used to be right there, and now it's right here after I've unwrapped it. The area of this region has a formula. It's called pi RL. So you can find the area of this shape by taking pi times the radius times the slant height. So this brings us to our formula. The lateral surface area, or this curved portion that isn't the base, has an area of pi RL. To find the surface area of a cone, we take the base area and we add the lateral surface area. So this is a different technique because you have to find pi RL rather than the area of the triangles. However, it kind of has the same idea. You take the base, then you add the lateral surface area. It's just that the lateral surface area looks a little bit different if you're working with a cone. And so, oh no, I've written on the back of this. All right, so let's do the second example. Find the surface area of a cone. So, remember our volume formula for a cone, or our surface area formula for a cone, which is just pi r squared plus pi RL. This is actually not too hard to remember. Just remember pi r squared plus pi RL. That'll tell you the surface area of a cone. Just remember, it'll really help you to remember that this is the area of the base, and this is the area of the lateral surface. L, in this case, L is a letter that represents the slant height. So here, 5 would be L. Let's plug everything into this equation. Pi r squared is pi times 3 squared, because our radius is 3. And we're adding pi times r, which is 3, times L, which is 5. So what happens? 9 pi plus 15 pi. And so the surface area of the cone is 24 pi. And the units are centimeters squared. I've just plugged it into pi r squared plus pi RL, and then I found the surface area. All right, next we're going to find the surface area of a cone. Another cone right here. Given that the radius of the base is 11 decimeters and the slant height is 17 decimeters. This one is not too bad because the surface area of a cone is always pi r squared plus pi RL. Then we replace r and L with the numbers that they gave us. R squared, in this case r was 11. So pi times 11 squared. And then we're adding pi times 11 times 17. So our surface area is 121 pi plus 187 pi. And so if we do combine those together, I get 308. That's right, isn't it? 8. Yes, 308 pi decimeters squared. All right, let's move on. A sphere, like we talked about last time, a sphere is a set of points in three-dimensional space that have the same distance to the center. And the formula for the surface area of a sphere, it's interesting, it kind of reminds me of the formula for the area of a circle, because the surface area of a sphere is given by 4 pi r squared. 4 times pi times r squared, which means that the surface area of a sphere is basically the area of 4 identical circles that have the same exact radius as the sphere you started with. It's so strange because I can't imagine taking 4 identical circular pieces of paper and kind of pasting them over a sphere. But yeah, this is actually kind of a cool formula because it reminds me of the area formula. It's just times 4. So let's do another example, okay? Let's find the surface area of a sphere with a diameter of 9 inches. Erasing this part. I have a sphere. I'm imagining a sphere. It's always very fun to draw spheres because you can do this and draw a little belt around the sphere and some dots just to communicate that you're talking about a three-dimensional sphere with a diameter, a diameter of 9 inches. Now it said diameter, so don't miss that part. Diameter means the length all the way across. And so if the diameter is 9, then the radius has to be 9 over 2, right? So 9 inches, the radius is 9 over 2 inches. We could think of that as 4.5 inches. We're asked to find the surface area, which has a formula of 4 pi r squared. So we plug in 4r, the value that we were given. 4 pi r squared, where our r squared is actually 9 halves squared. The reason I'm doing 9 halves squared is because typically I just do not like working with decimals. And in this case, it's going to make it really easy. Because look what happens. Got 4 pi and then 81 over 4 on the inside. And so we can cancel out those 4's and we're left with 81 pi inches squared. 81 pi inches squared. So we're using that formula, 4 pi r squared, and we get 81 pi inches squared. So here's a summary of new formulas that you should memorize, okay? Now that we are at the end of the lesson. Now just 1 second because I accidentally scribbled all over my notes. Here you go. This is what I would love for you guys to have written down. So, the surface area of a pyramid is the area of the base plus the number of triangles times the area of one of those triangles. I am going to just put an extra star or something around the formula for surface area of a pyramid. You really want to be getting these problems right because we're going to throw some curveballs, throw some crazy wackiness into the mix, and try to make surface area of a pyramid problems that are really confusing. That'll be, I think, it's like lesson 70 or something. We've got some really interesting reverse geometry problems. But anyway, these 3 formulas are what I need you to have written down. And you will be using these formulas in your homework. So for homework 23, I want to make sure that you're starting out by drawing a picture, then going on to writing out the setup, writing out whatever formula you need to use, and then solving based on the given information. So as long as you've got these formulas in your head, and you know them backwards and forwards, then you're really in good shape for the next test, which will be just an overload of geometry. All right, guys. Thank you so much for listening. I hope you have a lovely day, and I will see you tomorrow.